Hello. Today we are going to cover some more probability notes. This is Unit 12, Day 6. We're going to start with the definition of probability, as it states at the top. Probability is defined as the number of times something occurs divided by the total number of possible outcomes. Probability is going to be a ratio, a fraction, a division problem. A probability exists between 0 and 1, where 0 means that an event will never occur, and 1 means an event will absolutely, certainly occur. A probability will never be over 1. A probability will never be a negative number. Empirical probability of an event is an estimate that the event will happen based on how often the event occurs after collecting data or running an experiment. It's based specifically on direct observation or experiences. Theoretical probability of an event is the number of ways that the event can occur divided by the total number of outcomes. It is finding the probability of events that come from a sample space of known equally likely outcomes. First example. A fair die is thrown 150 times. It lands on 26 times. Empirical probability of rolling a 2 is... So based on this experiment, we would get 26 over the 150 times. Part B, the theoretical probability of rolling a 2. On a fair die, how many times does 2 occur? So on a die, 2 occurs 1 out of 6. So the theoretical probability of rolling a 2 is 1 out of 6. Next, probability with and probability with or. So let's first take a look at probability with and. When you have the probability of A and B, you find the probability of the event A, and you multiply that by the probability of the event B. So and means to multiply probabilities. Probability with or. To find the probability of A or B, you find the probability of A, and you add that to the probability of B. So or means add probabilities. Example 1. At a school fair, the spinner represented in the accompanying diagram is spun twice. What's the probability that it will land in section G the first time and then in section B the second time? So we are finding the probability of G and B. So we would find the probability of G and multiply that by the probability of B. So looking at the spinner, the probability of G would be 1 out of, and we're going to make a little dotted line in here so that our sections are equally spaced. We'll have 4 equal sections, so probability of G is 1/4. Multiply by the probability of B, which is 2/4. When you multiply fractions, you multiply across the top and across the bottom. So we get 2 over 16, which is 1/8. Example 2. Sal has a small bag of candy containing 3 green candies and 2 red candies. While waiting for the bus, he ate 2 candies out of the bag, one right after the other, without looking. What is the probability that both candies were green or both candies were red? Alright, so here we go. This bag contains 3 green and 2 red. And the probability is asking us to find the probability of green, green, or probability of red, red. The probability of choosing green, green would be 3 out of 5 the first time, and then 2 out of 4. The probabilities decrease because we're taking out a candy. Or probability of red the first time is 2 out of 5, and the second time would be 1 out of 4. So our probabilities will be 6 over 20 plus 2 over 20 which gives us 8 over 20, which reduces to 2/5. And that's it. The next topic in this unit is binomial probability, finding exact probabilities. A binomial experiment, there are two mutually exclusive outcomes, often referred to as success and failure. If the probability of success is S, the probability of failure is 1 minus S, because probabilities always add to a total of 1. Such an experiment whose outcome is random and can be either two possibilities, success or failure, is called a Bernoulli trial. Examples of Bernoulli trials are flipping a coin. For example, if you're looking for heads, heads would be success, tails would be failure. So it's either a yes or no situation. Rolling a die, getting a 3. 3 is success, all others are failure. Determining eye color. If you're looking for green eyes, that would be success. Anything else would be considered failure. When computing a binomial probability, it is necessary to calculate and multiply 3 separate factors. We need the number of ways to select exactly our successes, in other words, what you want to happen. So that's what we want. The probability of success raised to the power r, so that's probability of success raised to the power that we want, and the probability of failure raised to the whatever remaining of the possibilities are left. Let's continue to take a look at this. The formula for probability of an event occurring S times exactly R times is NCR, where NCR is that combination calculation that we did yesterday, times the probability of failure raised to the n minus r power, times the probability of success raised to the r power. All of these letters are defined. N is the number of trials, R is the number of specific events you wish to obtain success, S is the probability that event will occur, and F is the probability the event will not occur. So let's look at an example. Oops. We're actually going to use our new calculators to help us calculate these, but we're going to write it out first so that we get full credit. When rolling a fair die 10 times, immediately I know that's the number of trials. What is the probability to the nearest thousandth, rounding directions are important, of rolling a 4 exactly 2 times? So our R, the number of specific events we want to obtain. So what do we want to happen? We want exactly 2 4s. And then S is the probability of rolling a 4, and that would be 1 out of 6, because on a fair die, the 4 only happens one time. And the probability of failure, which would be everything else, so 1, 2, 3, 5, and 6, which would be 5 out of 6. Our would be written 10C2, probability of failure, 5, 6, probability of success. So I look at success first. I want the 4 to happen exactly 2 times. That has to match my probability of success. Then I subtract. 10 minus 2 is 8, so I have 8 left over. Then I'm going to use my calculator. I could just type all that in, but my calculator will actually find the binomial probability. So I'm going to make a little box here. Calculator. In my calculator, I'm going to hit Menu, number 5, Probability, number 5, Distributions, letter D, which stands for binomial distribution, and it says binomial PDF. And then a menu comes up on the calculator. And the information that I need to type in is my number of trials. So that's going to be 10. And then it asks me for the probability of just success, because the calculator will calculate the rest. So my probability of success was 1/6, which I can put in as a fraction. And then it asks me for the x value, which is the number of desired outcomes. So how many times did I want the 4 to come up? That would be 2. So these are the 3 pieces of information I need for my calculator to calculate the answer for me. I type them in, and then I write down my answer rounded. Alright, so our calculator screen will show binomial, PDF, and then we type in these 3 things, and the answer is 0.2907, which we look at the top, and we round to 0.291. And that's it. Alright, let's keep trying. Let's go to another example.